Today we're starting 3.6 arithmetic sequences. The main objectives for today is we're going to recognize and extend an arithmetic sequence and find a given term of an arithmetic sequence. Your first question probably is, what is arithmetic? That is a good question. What do you think arithmetic means? Yeah.
What they used to call that.
Math is called arithmetic. So we're doing a math sequence. We're going to talk about sequences, terms, arithmetic sequences, and common differences. During a thunderstorm, you can estimate the distance from a lightning strike by counting the number of seconds from the time you see the lightning till you hear the thunder. When you list the times and distances in order, it forms a sequence. A sequence is a list of numbers that often forms a pattern. A sequence does not have to form a pattern, but a lot of times it does. Each number in that sequence is called a term. So if I have, go back a second. All right, I guess it's going to do that. I have this set, or this sequence of numbers. 1 is 0.2, 2 is 0.4, 3 is 0.6. What's happening between all these numbers? It's increasing 0.2 every single time. That is the pattern. In the distance sequence, the distance is 0.2 miles. If you notice, it is always plus 0.2. That is called your common difference, which we call D. The entire sequence is called an arithmetic sequence because every single one is added plus 0.2, or added 0.2. The variable a is often used to represent the terms. The variable a9, we read it as a sub 9. It is the 9th term in a sequence. To designate any term or the nth term in a sequence, you can write a sub n, where n can be any number. So the basic formula for an arithmetic sequence is a sub n equals a sub n minus 1 plus d. So I have this sequence. We're going to determine whether the sequence is arithmetic or not. If it is arithmetic, we're going to find the next three terms. I have 9, 13, 17, 21. What is happening between each term? Each term, okay, the first thing we have to do is find the difference between successive terms. So each one was plus 4. Next thing we need to do is use the common difference. So we just said the common difference was 4. If I add 4, what's the next one? Next one's 25, then it's... So using the formula, we already know that it's 25, 29, 33. But here's the formula. What this means, in order to know the last term, I need to know the term before it. In order to find 33, what do I have to know? I have to know what 29 was. In order to know the next one, I need to know this one to move on. I can't go from the first term to the last term immediately. So this is term 1, 2, 3, 4, 5, 6, 7. To find a sub 5, I need to know a sub 4 plus my d. My d is 4. What is a sub 4? 21. And what's 21 plus 4? That's where it comes from. And I know that's what you're doing in your head, is just going plus 4 plus 4 plus 4. Where'd I get the 5 from? The fifth term. To find a sub 6. You got to know the one before to find the next one. A sub 6, I need to know a sub 5 plus 4. A sub 6. What's that? This isn't a sub n subtract 1. It's a sub n minus 1, which is the term before a sub n. It's the number less. This is a subscript and not a minus 1. And this is where some of you are going to make mistakes, is because you're going to write numbers really quick, and you're going to write a sub n and then put minus 1. And you're going to think it's subtracting 1. Just like this means what? This is x squared. But sometimes you write things sloppy and it looks like this. And you might confuse it with x times 2 or something times 2. To know a sub 6, a sub 5 is 25 plus 4 is 29. You need to understand the steps because you have to understand how to use the formula because you're not always given all the terms. Sometimes you have to work backwards or you have missing pieces. Those 3 dots at the end, I go back. See these 3 dots? That means it keeps going on. That has a special name. That name is called an ellipsis. And all it means is and so on. Some of you didn't know what that was called. You just put dot, dot, dot. It does not mean dot, dot, dot. It actually has a name. Here's this one. I have 10, 8, 5, 1. Is it arithmetic? What's the difference here? Difference here is 2. Here is. It goes down 2, down 3, down 4. Is that the same number all the way through? No. The difference is not the same. Since it is not the same, it is not arithmetic. Yes, you could sit there and figure out the pattern. You could figure out what the next 3 are in the sequence, but it's not considered to be an arithmetic sequence. To be an arithmetic sequence, it has to be the same number, repeated, over and over and over. If it went down 2, down 2, down 2, down 2, down 2, it is arithmetic. Do you understand the difference? Just because you can find the next 3 doesn't mean it's arithmetic. Just because you're using math to figure it out doesn't mean it's arithmetic. Look at this one. What's the difference between each one?
When you get negative 1/4, to get to 1/4, you gotta go to 0. No 0 counting another number.
Zero's 0. If I look between each one, it is adding 1/2. Now, I don't have to think of it as halves. What's happening between a negative 3/4 and a negative 1/4? What did I add? Added 2/4. How did I go from a negative 1 to a positive 1? I added 2. How do I go from 1 to 3? Adding 2/4. I can think of this as adding 1/2 or as adding 2/4. Either or. And actually, this one's probably going to be a little bit easier. Adding the 2/4. Now, the common difference is 1/2. So that means D is 1/2. Now the next three. What's 3/4 plus 2/4? 5/4 plus 2 more is 7/4 plus 2/4 more is 9/4. Do you see why it's a little bit easier to deal with the fourths than it was by the halves? Because some of you, when you try to do 3/4 plus the 1/2, I saw what you did. You tried to do 3 plus 1 is 4, 4 plus 2 is 6. That's a basic math mistake. That's a huge mistake. At least, what should I have done? I have to find common denominators, which is 4. If that's a 4, that becomes a 2. 3 plus 2 is 5. Try this one. When I look at this one, what's my difference between each one? The difference is add 2, add 3, add 4. Please don't just write 2, 3, 4. Actually, you can write 2, 3, 4. I will allow that, but if it's a negative, you need to put down, because you'll need to remember you're going down 2, 3, 4. Since it's going different numbers, it's not arithmetic. Now, sometimes you're going to have to find the nth term of an arithmetic sequence. Sometimes n's a large number. What's happening here? So I'm going to call this A1, A2, A3, A4, and this one's AN. Okay. The sequence starts with 3. The common difference you just told me was 2. We're going to use the first term and the common difference to write a rule for finding A sub n. First term's 3. 3 plus 2 is 5. Second one's, I take 3 plus 2 times 2. What's 2 times 2? The third one, I have 3 times 2 is 6. 6 and 3 is 9. So to find the nth term, I take the term minus 1 times 2. Some of you are confused here. All right. We know the terms are 3, 5, 7, 9. What's the next one? The fifth one's 11. The sixth one's, the seventh one is, the eighth one's 17. The ninth one's, and the 10th one's 21. Wait, yeah, 10th one's 21. So we already know that the 10th term is 21. But how about if I said, what's the 500th term? You'd have to keep going from 11, 12. It's going to take you forever, right? That's why we need this shortcut, this formula. This is what I'm trying to show you. If I use this algebraically, what is my first term? First term was 3. What is my n? All right, we'll use 10 because we know the 10th term is 21. Remember, second term is first, second term's 2, third term. So this means A sub 2, A sub 3, A sub 4. What's my D? What's my difference between each one? 2. Now watch, when I do the math. 3 plus, what's 10 minus 1? What do I have to do first? Multiply. What's 9 times 2? 18 plus 3 gets me 21. Isn't that what we just figured out? So how about if I wanted to know the 501st term? What's my first term? 3. What term do I want? 501st. There's a reason why I said that. Minus 1. What was my difference? 2. I take 501 minus 1 is 500. That's why I did that. What's 500 times 2? 1,000 plus 3 is 1,003. That means the 501st term in this arithmetic sequence is 1,003. It would take you forever to sit there and do it by hand and figure out plus 2, plus 2, plus 2. That's where this is used. That's why when at first you started saying, well, can't I just go plus 2, plus 2, plus 2? Yes, you can, but you need to understand the whole n concept. So we already have this written down. So here we go. Find the indicated term of the arithmetic sequence. So right off the bat, I'm telling you it's arithmetic. We want to know the 25th term. A sub 1 is negative 5, D is negative 2. This means the first term in the sequence is negative 5. The common difference is it's going down going down 2 every time. Figure out what the 25th term is. Now, before we run out of time today, the formula. A sub n equals A sub 1 plus n minus 1 times D. I substitute in the numbers. So to find A sub 25, it's equal to negative 5 plus 25 minus 1 times negative 2. Now I solve. What's 25 minus 1? 24 times negative 2 is negative 48, and negative 48 and negative 5 is negative 53. So that means the 25th term of this sequence is negative 53. I already know some of you on the test, when I say find the 25th term, you're going to sit there and do 1, 2, 3, 4 until you get to the 25th because you forgot this formula. That's fine, but it's going to take you a while. We okay?